Welcome to Lecture 2 of the Sustainability Module for Civil 896. My name is Colin McDougall. As we started to discuss in the last lecture, the things that engineers design and build use large amounts of energy and materials, and so have significant impacts on the natural environment and, in fact, human health. So there have been many attempts to try to quantify some of those impacts. And I'm going to focus in this discussion specifically on buildings. So as one example, this is a study specifically related to Canada, the Royal Architectural Institute. Their research showed that the design, construction, operation of buildings are the main sources of demand for energy and materials out of any sector in Canada. And in fact, according to their numbers, buildings account for nearly half of all greenhouse gas emissions in Canada. As we move to the United States. And this is a study from the U.S. Energy Information Administration in 2009. Their numbers indicate that the building sector accounts for about 26%, so a little bit less than the Canadian study of carbon dioxide emissions. Still sticking with the states, this is another study. In this case from 2006, a Pew study. The sector that they identify as buildings, they say accounts for about 43% of carbon dioxide emissions. Back to Canada again. This is another Canadian study, this case from Environment Canada, published in 2013. And they were tracking greenhouse gas emissions for various different sectors, and they have this one sector identified as buildings, and they tracked greenhouse gas emissions. So these are megatons of carbon dioxide equivalents over a number of decades. But specifically, if we look sort of at more recent data, the amounts of these emissions specifically related to buildings actually only accounts, according to their numbers, for about 12% of total greenhouse gas emissions. So what do all these different studies tell us? There are obviously some different numbers out there, a whole different range of estimates of the impact of buildings on the environment in terms of at least greenhouse gas emissions, which we know can be related to climate change. Why these different numbers and which one is right? Well, keep in mind that in each of these different studies there may be different accounting methods, so what specifically they define as buildings and how much is accounted to buildings may differ. Some of these papers you actually find it's a bit difficult. They are not really explicit in terms of how they actually define what a building is and what falls into that category. Of course, different countries, we can expect some differences in terms of impacts in different sectors. And certainly even in this comparison between two countries, Canada and the States, we see some different numbers. And of course, there are some different metrics that in the different studies that I was looking that I described, they're using some different metrics. So for example, carbon dioxide emissions are somewhat different from total greenhouse gases or greenhouse gas emissions. So the main point is we have some different studies, some slightly different numbers, and in fact in some cases some wildly different numbers. But regardless of which numbers you look at, there is little doubt that we can identify some big impacts in terms of energy, in terms of greenhouse gas emissions that are related to the buildings that we as engineers design and that society operates. So given that large impact, engineers are being asked to actually assess that impact and to assess how green and sustainable our built environment is, and really to try to come up with ways of making it more sustainable in the future. And so all of this is really the motivation for some tools that have been developed in about the past 20 years that sort of fall under the title of building assessment methods. And these tools have been developed as a way to try to quantify the sustainability of a building project. There are two main groups of these building assessment methods. The first are qualitative tools, and the second are quantitative tools. So qualitative tools involve developing some criteria and scores. So a little bit simpler to use, as we'll see. Quantitative tools are more holistic. These tools try to use a full life cycle approach with input on the materials and the energy that's being used to come up with some way of measuring the impact of that building over its entire life, the impact that it will have on the environment. So these quantitative tools are complex to use because buildings really are complex systems. This is a flowchart from these authors from a paper in 2010, and really their main point is that buildings have many subsystems. Some of these can be quite complex to try to quantify, and the timescales we're looking at are long. So buildings, at sort of a minimum, will have a design life of 50 years, and often are expected to last much longer than that. So all the way from things like the materials that we use and how they're actually acquired, how they're extracted, how they're transported, will have different impacts on the environment. The actual construction process itself will have impacts. And then, of course, the operation, the energy that's needed to use that building and maintain it has impacts on the environment. But at the end of the life of that building as well, there are a whole other host of impacts as that building is demolished and as materials are removed. What happens to them? Are they placed in a landfill site? Are they recycled? All of these will have some different environmental impacts. So kind of tracking all of these things gets quite complex. There's a lot here to keep track of, and keep in mind, of course, that while we can look at the environmental impacts, and so impacts on things like land, water, and air, many of the driving things, the things that will actually drive the design of a building, come down to things like economic costs and functional requirements. So all of these things have to feed into the design of the building, and the environmental impact really becomes, in many cases, just one factor out of many. So there's a lot here for design engineers in a typical building project to try to handle. So these types of quantitative assessment or life cycle assessment schemes are not used a lot in practical design situations, although they will be used very often in research environments. Instead, to great extent, the industry has turned to this second group or second type of building assessment scheme, which we refer to as qualitative schemes. So these are much simpler, and basically what happens with these schemes is that certain parameters are identified as what the authors or the developers of the assessment scheme believe to be the critical parameters. These are typically things like the site that's chosen, the potential of the site. In some cases, they may try to address things like preservation of regional cultural identity. One critical one often looked at is energy consumption, trying to minimize that, as well as protection, conservation of water resources. They'll also often try to encourage the use of environmentally friendly materials, products. Also trying to ensure a healthy and convenient indoor climate. So looking at, for example, the indoor air quality. And of course, looking at the maintenance practices and trying to improve the operational and maintenance practices. So they kind of identify these various different parameters, and what they come up with is what we can very kind of crudely refer to as a score. You sort of get a score for how well you improve the environmental friendliness or the sustainability of each of these different parameters. There have been, over the years, so I said, really these things have been developing over the past 20 years. There are many of these methods that have been proposed and developed. But what you're finding is that increasingly these, many of them are falling by the wayside, and there are really just a few, really two major international assessment schemes that are really coming to the forefront and that are being used by the majority of engineers and those looking at the sustainability of buildings. Why is this happening? There are a number of reasons for this, and these authors, if you're interested, have a really interesting paper on these building assessment schemes, and they go into more details about the history of this. But one of the main reasons for this is this idea for brand recognition. So as engineers work increasingly in different countries, they want to be able to use an assessment scheme that is easily identified and recognized in other countries. And side by side with this is the desire for international standards, so standards that sort of will be accepted across a wide variety of different countries. There's another kind of really sort of other important part of this. So these assessment schemes are not public property. They're actually owned by companies, by developers who came up with these schemes in the first place, and they want to make money. So they have they work very hard to try to promote their particular assessment schemes so that it's adopted by more and more engineers and recognized around the world, essentially so that they can sell more of their product, of the use of their particular assessment schemes. Okay, so the two major assessment schemes that have really come to the forefront, one is an earlier, developed certainly a little bit earlier than the other, and that is the Building Research Establishment Environmental Assessment Method, luckily shortened to BREEAM, and that was originally developed in the United Kingdom. And the second scheme, which was developed originally in the US, is called Leadership in Energy and Environmental Design, and usually referred to, for the most part, as LEED. So this is some data, again from Cole and Valdebenito, looking at the use of LEED and BREEAM. So some interesting sorts of trends. First of all, keep in mind that the data, it's not an entirely fair comparison between these two. The data that they have in this table for LEED is between 2000 and 2012, whereas for BREEAM it's between 2008 and 2012. So a much longer period of time for the data for LEED. So keep that in mind, it's a bit skewed. You can see that LEED has been moving out very aggressively from just the States and is now being used or recognized in about 135 countries around the world. BREEAM, not quite as far a reach in about 34 countries. Here you can see the huge growth in LEED and BREEAM as well. So really LEED would have been developed in the late 90s, early 2000s, and you can see that it has been used in over 47,000 projects, almost 2,900 for BREEAM. And here you can see the breakdown in terms of the numbers of projects outside the US or outside the UK, so fair number. Many of these for LEED would of course be in Canada. Over here, another interesting number. So APs is accredited, stands for accredited practitioner. So these are people who take a course or a series of courses from LEED or BREEAM, obviously at a cost. They pay for these courses to become, accredited to carry out the LEED or BREEAM building assessments. So you can see LEED has accredited an enormous number of professionals, over 160,000. BREEAM, much more modest numbers in that category. But the main point here is that there's been a huge growth in this, in the use of these assessment schemes, and in the numbers of people accredited by either LEED or BREEAM. The next few slides are really just kind of talking in a bit more detail about what is actually part of a LEED assessment. This is the group that originally developed the rating system, U.S. Green Building Council, and they really claim that it's a way to quantify how green a building design is. So this is how it sort of breaks down. They have identified 6 categories, so you can see them here. One they call sustainable sites, water efficiency, energy and atmosphere, materials and resources, indoor environmental quality, innovation design processes. Okay, with each of these categories they have assigned a certain number of what they call points. Sustainable sites is 14, water efficiency, for example, is 5. So you see different numbers of points to each of these different categories, so obviously giving different weight to the different categories. And each of these categories then has a variety of different criteria. We'll look at that in a minute. And if you meet those criteria, you earn points within that category. So let's look at this example. This is from Da Silva and Ruapura from a 2009 paper. Again, I would, lots of interesting stuff being developed in the literature around some of these assessment schemes. So if you want to get some more information and really some interesting literature, some published and peer-reviewed literature, go to the literature and take a look at what some of the researchers are saying out there about some of these assessment schemes. What they're looking at, or this is really just a table to show what LEED looks at in this materials and resources category. So they have it broken up into a bunch of different subcategories, and just to give some examples here, for example, building reuse building reuse. So if you're taking existing building materials, building components, and implementing them in the design or the construction of a new building. Construction waste management, diverting different percentages from the landfill. Recycled content, so implementing recycled content in your construction materials. Using local or regional materials, or using rapidly renewable materials. Okay, so these whole host of different types of things you can try to do, and if you actually can achieve those, you get various points. Now, the reality is that, of this is that some of these are quite easy to achieve, others not so much. So they looked at a whole host of different LEED projects that had been certified. The different colors here are indicating different levels of certification that LEED identifies. So the gold and platinum certification is sort of the highest certification you can reach. Silver is kind of in the middle. Certified is the lowest. Okay, what they're looking at in this graph is for these different kind of subcategories in the materials and resources area, the percentage of projects that obtained these different points. So you can see some, no one even attempted. No one was able to achieve some of these points. But there are some which, virtually, either 100% or 90%, almost everybody is achieving. So the question is why? So to give some examples, for example, this waste management, these points, virtually everybody, close to 90% of the projects are achieving that. The recycled content, 90 to 100% are achieving that. The local regional materials points. Okay, why might that be? Well, the waste management, many municipalities already have now systems for recycling materials, diverting materials away from landfill. So that's sort of already in place. So it makes it pretty easy on a construction project to, just follow the normal recycling procedures and claim your point. Recycled content. Some of this is already, pretty standard. For example, cement currently uses, certainly in North America, Canada, the U.S., a lot of cement uses fly ash to offset the amount of cement. Fly ash is, of course, a waste, considered a waste material from the burning of coal, and in the past, in the 1970s and 80s, essentially would have just been diverted to landfill. It's now being mixed with cement and used to offset cement. So it's pretty easy to achieve or say that, yes, I'm using 10 or 20% recycled content in my building materials. And then local regional materials. Part of the reason this one can be quite easy is to achieve is if you're in, depending on your location, the sort of radius that LEED defines as local tends to be pretty big. So if, for example, you're in southern Ontario, it's not that hard to obtain your materials within, a 200-kilometer radius or an 800-kilometer radius, and then claim that, yes, I'm using local materials. If you are in a very remote region, for example, in Canadian North, these sorts of points would be very, very difficult to achieve. So all of that is just to say that there, the idea is to encourage sustainability, but you need to dig down a little bit deeper to see whether people are really making changes and really making improvements as they try to achieve this LEED certification. So to kind of sum up, how LEED does this, they would look at all these different categories, the different criteria that you've met. You get these various points. All you do is you add them up. You'll get a certain total number, and then depending on where your total score falls in this range, you see pretty random numbers of points, pretty random ranges. They will give you certification. So as I mentioned, the lowest is certified. The highest is what's referred to as platinum. So these assessment schemes become very popular. Many municipalities now require buildings, municipal buildings, to be LEED certified, for example, in Canada. But there are many criticisms. Okay, there are many criticisms, and as engineers, we should keep these in mind as we're using these and considering what they really tell us about sustainability, and whether they're helping us to really achieve sustainability. So again, going back to this paper by De Silva and Ruwan Pura, one of the things they say is that technical merit is one of many factors, is only one of many factors considered in the importation of assessment methods. And these decision processes are often not well documented. What do they mean by that? So these different categories that LEED, for example, is using, why those categories? What is the connection between those categories and the different criteria that they're specifying and actually achieving a more sustainable building system? In fact, as you start to dig into some of these categories, you realize that there are things that that really don't make sense. So in this materials category, for example, they have this rapidly renewable materials. If you use rapidly renewable materials, you get a point. So, one rapidly renewable material is very rapidly renewable is bamboo. So designers have sometimes specified bamboo flooring, and you get a point from LEED for specifying that. But that very much is not a regional material if we're talking about Canada. This would be imported from Asia, and so it really contrasts with this goal of trying to obtain local materials and hence try to reduce the transportation of materials from long distances and the resulting emissions from transporting those materials. So there can be some real paradoxes and real contrasts in some of these points that are awarded. And why these different numbers? For example, 10% recycled material, you get a point for that. What makes that equivalent to, say, increased ventilation, which you would also get a point for? And using 10% recycled material having increased ventilation, what impact does that have long term on the sustainability of that building, and on a global level, on actually improving the improving our environment? These the reasoning behind these decisions in LEED is not clear. There's not a lot of information provided by LEED on how these decisions were made, and so keep in mind that oftentimes these categories and the criteria that were used were really set up not necessarily with strict scientific basis, but on the basis of what is something that can be achievable by industry, okay, without causing a huge impact on industry or a large economic penalty on construction companies. Another criticism. So, as they say, technology is not value-free. All assessment methods carry the values and priorities of their developers, either implicitly or explicitly. So to look at some examples of this, the idea is that one of the points that you can earn is if you're using a LEED accredited professional, in that previous table, LEED APs. So if you use a LEED AP on the project, you get a point. Well, it's a bit of a conflict of interest, considering that you can only become accredited by taking and paying LEED for their course. So they're really basically saying, if you want to get this point, come and pay us even more money to become accredited. And thinking back to the first lecture, the original Brundtland report, where the definition of sustainable development was first made and kind of fleshed out. And remember that the authors of the Brundtland report were pretty adamant that sustainability involves not just the technical sides of projects or of development, of building, but some of the broader, more complex social aspects. So things like promoting equity and fairness, actually involving people in the design and construction of their buildings, integration of stakeholder knowledge, understanding contextual issues. These are not really part of LEED and the various different categories that LEED examines or gives you points for. Okay, so to summarize all of this, and in fact I really just went through a little bit on LEED and some criticisms of LEED. BREEAM works in a similar way, and there can be some similar criticisms of BREEAM as well. But to just summarize, obviously as engineers we face increasing pressure to be seen to reduce the environmental impacts of our built environment, because it truly does have a big impact on the environment. And one of the ways engineers have tried to address this is by using these building assessment methods, and the two primary ones that have come to the forefront have been BREEAM and LEED. Certainly it's at least getting engineers to think about sustainability. It's trying to make some improvements and some progress. Keep in mind though, as you use these methods, they are certainly commercial products. They're not necessarily fully based on technical considerations or the full range of considerations for sustainable development, at least as envisioned by the Brundtland report. So once again, as with any of these lectures, if you have questions or comments, talk to me. Probably the easiest way is through email, but certainly also feel free to call me as well at Queen's University. Thank you.